Welcome to Spring LIB.
Part A of this question asks us to find the average velocity. And so we're going to do that using this formula. We know t2 minus t1 is 10 seconds, but we need to know what x2 and x1 is. And we can get that by using the given form of x of t and plugging in appropriate values of t. Specifically, we need x of 10 seconds, and we need x of 0 seconds. X of 0 seconds is easy. It's just 0. But x of 10 seconds, we have to remember that b and c are these values here. And so we're just going to plug in 10 seconds for t here, and then b there, and c there, and then use a calculator. And once we do that, we get that x of 10 seconds is equal to 120 meters. Now that we have these two values, we can use the average velocity formula here. And we get 120 meters divided by t2 minus t1, which is 10 seconds. And so the average velocity is 12 meters per second. Onward to part B. Part B asks us for the instantaneous velocity at 3 different time values. To get the instantaneous velocity, we take the derivative of this function. And so we do that by just applying the power law. And we get that the instantaneous velocity, v of t, is 2 times little b times t, just by bringing down the power of 2 and then subtracting 1 from the exponent. And then the other term equals 3c t squared. Now we know what little b and little c are, and so if we are given a time value, we can just plug this in and figure out what the velocities are. So we need v of 0.0 seconds. And this one is still easy because we just plug in 0 and 0 there. It just yields 0. So we get 0 meters. We also need to plug in v of 5.0 seconds. To actually do this, we'll have to refer back to these two values. And again, this becomes a calculator problem. And once we plug that in, we get 15. Oh, by the way, these are meters per seconds because this is velocity. And then we need a last one, and that's v of 10.0 seconds. Plugging this in again and using the same b and c values, we get 12 meters per second. And so now we move on to part C. In part C, we need to know the time value so that the velocity is 0. We know what v of t is. We got it in part B. So plugging in 0 for v and then solving for t here, we have 0 equals 2b times t minus 3c t squared. I'm going to cancel a factor of t and then move the 3ct over. We're solving for t, so I'm going to divide by 3c. And b and c are known constants. They're here. Whenever we plug them in here, along with the 2 and the 3 into our calculator, we get that t is approximately 13.33. By the way, this repeats forever. And that's in seconds. And so approximately 13.3 seconds after it starts, it comes to rest again. And so that's the final answer for part C. And that's the end of the problem.